Hi all, welcome back to operating system course. So today we will start our next chapter, that is chapter 2. The name of the chapter is process management. And in this process management you'll study what do you mean by a process, its state, process control block, that is PCB, threads, scheduling, then what are the operations on the processes, how the process communicate with each other, then the scheduling concepts. Okay, so let's get started with the basic introduction first. Earlier in the old systems, they allowed only one program to be executed at a time. So that particular program had complete control of the system, and it had access to all the system's resources such as your CPU, IO devices, etc. On contrary to this, that is today's computer, they allow multiple programs to be loaded into the memory and executed concurrently. Now, this evolution required far more control and more compartmentalization of your various programs, and these needs have resulted in a notion of a process. Okay, now what is a process? So, as we had seen in the first chapter, a process is nothing but a program in execution, right? And a process, whenever it is getting executed, or your program whenever it is executing, it needs resources, the resources such as CPU, memory, files, IO devices, etc. Now, a process is the unit of work in a modern time sharing system. The more complex your operating system is, the more it is expected to do on behalf of its users. So, a system is therefore considered as a collection of processes. Okay, operating system, it processes executing system code, and user processes executing user code. Okay, so let's move on to a process concept. Okay, so we already know the process and what are the things it needs whenever it is executing or your program is executing, right? So here the first question that arises is, whenever CPU is doing its activities, right? What do you call them? What is the name that you give to all the CPU activities, right? Your batch system, it executes jobs, but time shared system, it has user programs or task, right? So even in a single user system such as Windows, a user may be able to run several programs at one time. That is, he can run a browser, processor, email package, etc. And even if a user can execute only one program at a time, the operating system may need to support its own internal programmed activities. Those are your memory management. So, in many respects, all these activities are similar, so we call all of them as processes. The terms job and process we will be using interchangeably. Okay, job as well as process, that means one and the same. Okay, so sometimes I may say job and some other time I may say process, so do not get confused with these things. Okay, so here in the process concept you have to know what do you mean by a process. Okay, so process is nothing but your program which is in execution. Okay, now program, it is a piece of code which may be a single line or million lines of code. Okay, basically you can take an example of your C program, basic C program, right? So that is a program. So whenever you execute this program, we call that as process. Okay, so next we will study about how the process looks whenever it is in the memory. Okay, so as we all know, whenever you create a program or job, that would be saved in a job pool, right? I had given you the example of market. Hope you remember this one. So whenever that job has to be executed, or the program has to be executed, it has to be brought into the main memory. And this is how your process look like whenever it is in the memory. So when a program, okay, which is loaded into the memory, it becomes a process and it can be divided into four sections. That is stack, heap, data, and text. Okay, this is how your program looks whenever it comes and sits in the main memory. Now what does this stack do? So your process stack, it contains temporary data such as your methods or function parameters. Okay, and it also can contain return addresses and local variables. Got it? Your stack can contain, or it basically contains temporary data. Okay, it contains temporary data. So the data can be your method or function parameters, return addresses, and local variables. The next one is heap. So this is dynamically allocated memory to a process during its runtime. I'll again explain this later. Okay. Next we'll talk about data. So this section contains your global and static variables. Okay, it contains global as well as static variables. The last one is text. So this includes the current activity that is represented by a value of program counter and the contents of processor registers. PC contents and register contents will be there in this text. Okay. So now let's come back to this heap again. So this heap area, this it contains, or it helps in dynamically allocating the memory during the process runtime. So what do you mean by dynamically allocating memory, right? So dynamic memory allocation, it provides the flexibility to the execution of the program by allocating the memory space during your execution or at the runtime. So for example, um, maybe in the data structures you have studied malloc function, right? malloc, or you have new system called free. So these all things come under this dynamic memory allocation. Okay, so now this process, whenever a program it comes, and whenever a program is loaded into the memory, so it looks something like this. So a program has four parts, or basically we call it as a process. It has four parts: stack, heap, data, and text. Okay, one thing you have to understand here is your program is a passive entity. That means program is a file, right, which contains set of instructions. Basically, your executable files are programs, and those are passive entities. But your process is an active entity. It has your process as program counter and other associated resources along with it. So then how do you load that particular program or a passive entity? How can you load that to a memory? So there are two ways to load the process into the memory. So the first one is like just by double clicking on your icon which represents your executable file. This is one way to load the program into your memory. The second way, you can use the command line. Okay. Next, we'll study about the process state. So whenever your process it starts executing, it will change its state. Now, the state of the process is defined in a part by the current activity of that particular process. What is the current activity? What is it doing? Your process that defines the state. Okay, so your process can have multiple states such as new, ready, running, waiting, and terminated. Okay, so these are the five states your process will have. So, what is this new state? So, whenever the process is being created, it would be in a new state. Okay, so whenever you create a process, or it is being getting created, then it would be in a new state. Okay, then it is running. So instructions are being executed here. That means it is in your process is running. Okay, your instructions are being executed. That means it is in running state. So waiting, what does it mean? So the process is waiting for some of the event to occur. Maybe your IO, or IO means your input output event, or it is waiting for some receiving some signal or something. It is but waiting for something to happen. Okay, then is ready. Now ready means the process is waiting to be assigned to the processor. Your process is waiting for the processor here. Ready means. Last one is terminated. This means the process has finished its execution. Okay, fine. So this is the diagram for your process state. So first thing, whenever a process is getting created, it would be in a new state. Then once it is waiting for your processor, that would be in a ready state. That means your operating system will understand that you can assign the CPU to this particular process. Okay. Then it would be in a running state. That means, say suppose from ready to running, when it goes is like, whenever for that particular process you assign the processor, it starts executing the instruction. That means whenever execution is going on, that means the process, we say it is in running state. Okay, say suppose whenever a process is running, it wants some IO event to occur. Okay, it wants some IO event to occur. Then what it can do is like, it can, or it will go to a waiting state, and whenever this IO event is completed, it would again move to the ready state. Now what will happen in the meantime is, so whenever a process is in a waiting state, your processor can go to another process which is in ready status and can start executing it. Okay, I'll repeat once again. Whenever a process is in a waiting state, your processor can pick up any other process which is in ready state and start executing it. Okay, fine. So say suppose the process which was waiting for an IO that has been completed, now that particular process it moves again back to the ready state. Again, your processor should be allocated to this process, and when it starts executing, again it will move into a running state. Now remember, from running state your process can go back to this ready state, this one. When this can happen is whenever you have an interrupt. Okay, whenever you have interrupt, the process which is executing or which is in running state can move back to the ready state. And once that interrupt it has been handled, again that process can be picked up and it can be executed. And say suppose your entire process has been executed, then that means it has completed its execution. All the work which has been assigned to that process has been completed, right? That time your process will get terminated. That means it will exit. Getting it? So this is a process state, and this is the diagram for it. So the process states are new, ready, running, waiting, and terminated. You should understand when from running on what will happen, right? From running to ready, on which status it will go, and from running to waiting, when will it come, waiting to ready, when will it come. So this is a basic thing here. Okay, that's it for today. We'll conclude our session. Thank you.